We are live now. The class is being recorded. This is another section, day 8 on IT Foundation and AWS Cloud Training, codename iFACT. This is Josiah again, the lead instructor, and this program is supported by Loveland LLC, and implementation partner is Each One Teach One. So today we are going to rehash a little bit on what we've done previously, and happy to have all of you here with me. We're going to go through, first I would like to be interactive at this point. I want to know from each and every one of you the problems that you're having. That way I know. So that I would like to know. That way I will be, we all be on the same page, basically. I forgot the right word to use for it, but I think we are being on the same page is no better way to say it. So I had a chance to work with Natalie, and I recognized some of the issues that she is having. I hope I was able to fix it for her. So in that same spirit, I wanted to know what other people are going through. Judine just told us what she's going through. Now I know she's going through that, and I'm going to try to see how we can solve our problem before the next class. Now, if there's anyone here who feels like I need to know what they're going through as far as their homework is concerned and learning the technology. My interest is in you learning the technology. That's why I'm very open to taking calls at any time. I don't care. So, who is going to be the first?
Hi, Josiah. Can you hear me?
Loud and clear.
Okay. Good evening, everybody. So I followed up with what we discussed. So I'm back up to the point of where I was attempting to download the power tools, but I'm stuck there. I'm now on everything, all that part sorted now.
Oh, awesome. I'm happy. Glad to hear that. So you try to do the AWS CLI, or you got that?
I've done that. I went into the command box and typed in AWS version, and it's there.
Oh, awesome. What else did you do? You configured it?
I configured it as well. Put in the that it's JSON, the region, and the key, the security key, and the secret key.
Yeah. So once you did that, maybe you would have typed in AWS S3 LS, so you can see everybody that have created S3 bucket. Or maybe you should have typed another thing to see something else, But I'm glad.
What was that command you just said? Sorry, what was that command you just said? AWS?
AWS space S3 space LS. So when you put that command, you should be able to see everybody that have an S3 bucket set up. And another interesting thing is,
cool.
Did you see it?
Yeah, it's there. I'm gonna take a screenshot right now.
That's right. That's what I'm talking about. Now, another cool thing that we can do is this. I'm gonna do alternate print screen. I'm gonna take this alternate print screen and I'm gonna put it on a Riot room, and I'm gonna ask those of you that have done that have downloaded our app, to go and supply me this screenshot so I can get it in our repository in AWS. So these are real life scenarios. We are playing it out. So I'm gonna put it in our we have text area, cloud. We don't have picture area. So I just put it in the picture area then. Would that be a problem? I mean, I just put it in the text area. Would that be a problem, guys? Nobody says anything, so I'll go ahead and put it here. So I took a screenshot of every one of us. Oh, actually, I'm gonna do 2 screenshots so that we can use this to do our roll call. I just take a screenshot and I send it to anyone that wants to do the roll call. You see, we are developing we're creating cases because we're using tools. So humans are creative, evolving creative beings. So we see something, we figure out how to use it to better ourselves and stuff like that. So I put it on there, and the whole idea is for you guys to take this two pictures and send it to me. Unfortunately, something went wrong, and I don't know what that is. All right, it seems like we got cut off for a minute, and now everybody's back. Everybody back? Where are my people?
I'm here.
Good.
I think it dropped because it just got me out a little bit.
I think everybody got dropped except for me.
Yeah.
So that tells me it's the network we're using. I need to upgrade the network, guys.
You got to upgrade, Josiah.
I got to because this is not right. How can you guys be bumped up except for me? That tells me it's me in the end. Because y'all are not in the same location. Only me, one person in this one location was on, then is me. So moving forward, next, who's next? Each person have 2 minutes. So we've given it 22 minutes. 15 minutes already. We have about 14 more minutes. Is Laban here? Is Betsy here? If Laban here, can you raise your hand? Is Nicole here? Nicole Robbins? Yeah, Nicole Robinson. She's here. Awesome. Is Janelle here? Janelle Lovett? Yeah, she's here. Okay. Rolanda is here. Charity is here. Judine's here. Hannah is here. I don't see Aziat.
Azab is on. She was having issues logging into Riot, so she's using
A different
Hana's
person's
login.
computer. Yeah.
So yeah, Azab is on and Hana is on.
Oh, okay. All right, cool. Let's kick it off then. Since there's no more stuff going on here, we're just gonna kick it off. Today, we're going to do a little bit of networking. And before we do, we rehash what we've done in the past. We pretty much did everything we could on the aspect of AWS CLI, getting ourselves started off with the AWS, setting up a GitHub account, setting up our IAM account, accessing the console with the IAM account, and then downloading the AWS CLI tool and installing and configuring it, and also AWS tools for PowerShell. I think Natalie liked to call it Power Tool. But that's interesting. The way she came up with that word, I like it myself. So, with that being said, we are on our way to doing big and great things. And we have an understanding of hardware, software. We've talked about the software, and we know we'll talk about the languages. We will deal with languages. We'll learn Python to be precise. But before we do that, I would love for us to look into um, networking. So once we look into networking, we just piggyback off and go right back to doing a little bit of Python. And I need you guys to take a look back at those books that I have given at the early stage. The one book from Swarup, Python for Beginners, one book for Swarups. It goes in an ascending order, difficulty increases as you read it and stuff like that. And then there's another book by a guy named I forgot his last name. It's a real life scenarios of what you can write, use Python. Some of the problem you can use Python to solve was very amazing, and those we'll go through. But today, I'd like us to go through network. Okay. So there are a few facts about network I wanted to go through with you guys. It's always good to have a background before you do anything that you wanted to do. So I don't know. Do anybody know? Does anyone here know when? Well, the original name for the so-called internet and when it got started?
Wasn't it the World Wide Web?
Yeah. Yeah, I mean, the internet, well, maybe I should take the question again. I didn't get it right. So, like, basically, I was trying to say, what institution or what arm of the government came up with the internet itself? That's probably what I was actually supposed to say.
Was it the military?
It was the military, and it was through one of their agencies called the ARPANET. ARPANET. You can Google that. ARPANET. ARPANET. The military were working together with institutions in the U.S. So Advanced Research Project Agency Network. That's who came up with the internet. So in time, we'll learn quite a few things about the difference between the internet and the web. So the reason why I'm really focusing on the network is for you guys to have that understanding of what a network is, so that in the big picture you have the understanding of what a network is. Then it will be easy for you to do whatever you need to do in the cloud. So with that understanding, then you can achieve a lot and you can do a lot. That's the whole idea. So now I think I'm going to share the book with you guys, because a lot of people don't look into that book. I think y'all should, because I'm very detailed when I try to explain stuff, but you should still look at the little book, because we're developing that book together here. And just give me a minute, I'm going to share this. So it's being shared now. I hope you can see it. Yes, you can see it. So internet was invented by ARPANET in 1983. And do you guys know in 1983, well, 2 years after the Sputnik was sent out there, I think the saying goes that the phones that we use today is more powerful than all the computers that was in the United States put together at that time. That's how the saying goes. So that tells me that we have powerful tools in our hands today, and we should really be careful about how we use them and be conscious of our privacy and security. So internet is controlled by 75 million servers. That's an estimation. And backbone of the internet is made by 550,000 miles of underwater cable. So when they say this, it's like cable from US to China, China to Africa, Africa back to Europe, Europe back again to this region, Western Hemisphere. So that's what they're talking about. About 1 billion computer systems are connected to the internet. So there are 8 billion people approximately or more in the world. And the like a tenth of that are on the internet. Okay, so about 3.2 billion people use the internet, from which 1.7 billion internet users are Asians. So what does that tell you? There are a lot more Asians on the internet than anywhere in the world. And then there's also something I was reading online. It tells me that, according to Google information, you can Google that people that look like us over-index every other people except for the Asians. Okay, moving forward. So 1.7 billion. That's a lot on the internet. Interesting. So having computers on the internet and having people on the internet, these are two different things now, guys. Computer on the internet and someone, a user on the internet, is different. Okay, so let's move forward. If the internet goes down for a day, approximately 200 billion emails and 3 billion Google search would have to wait. That's why you should have a storage space and use all these cloud spaces and store all your information. Well, anyway, you should have a local storage. Cloud is not going to help you at this time if the internet goes out. So you should have a local storage somewhere at your house where you can take all the books that you love that are in the digital form and you save it up and keep it there just in case the internet goes out. You know, if the internet goes out, cloud is going to go out too. So remember that. So approximately 204 million emails per minute are sent over the internet every minute. 70% of them are what? Spam. So that tells us some people are making money from email. So that is why it's so difficult for me, with the kind of last name I have, to send a message to somebody in UK or Japan. So they all have algorithm that keep certain people out, okay, because of the bad eggs. So there's so much algorithms out there. They can make your voice crack. They can make your email go round the loop and comes right back to you. And it's all kind of stuff that's out there. That's why we're learning this, so we can understand how things work, so we can build systems that support and promote us. So moving forward, 269 billion emails are sent per day. Now, these are two different things. It says approximately 204 million emails per minute are sent over the internet. But it says 269 billion emails are sent per day. So that will include emails sent from your phone, etc., and etc. That's 269. Now, 30,000 websites are hacked every day. Pay attention to this one. 30,000 websites are hacked every day. 50 million horsepower is required by the internet to keep running in the current states. 50 million horsepower. You can Google that. Now, approximately 9 million adults in Britain and 1/3 of Italians have never used the internet, while China has treatment camps for internet addicts. So Chinese people are way into the internet usage, and why the British people are still not really with the program. Okay, 9 million adults in Britain and 1/3 of Italians have never used the internet. I don't know, this could be for a lot of reasons. Maybe they don't want to leave a footprint in Babylon, or they figure that they don't want nobody to watch or track them. It's not because they're not smart. So we shouldn't.
It's because in the UK there's like so much CCTV, and there's a combination of being overwatched, so people want privacy, and also as a culture the English are very arrogant.
Spoken by the Brits themselves.
I'm not British. I live in Britain, but I'm not British.
Oh, you're not British. Okay, I get it. I know exactly what you meant by that. So Microsoft has more servers than Google, right? Microsoft owns over 1 million servers, while Google has 900,000. We're not just reading this just because we want to read stuff. There's serious information here now. Pay attention. Now, when I say, oh, be careful with your information, Google, da 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 da, these are tracking mechanisms. You heard it. She says CCTV and all the other cross checking and what they call triangulation of information, data source, and points. They all plays a role, okay, in our exposure. So internet bots and malware generate 61.5% of nearly 2/3 of all the website traffic. You see, the website traffic, meaning the internet traffic, right? 61% ain't no good. Do you see what the reason why you should pay attention to your online privacy and your data? Okay, let's keep reading. 2/3 of all the website traffic, okay, or nearly 2/3 of all the website traffic, that's what it's saying, approximately 1.7 trillion euro dollar worth of funds is spent online. And that's what black people spend every year. 1.7, well, if you change that to dollar in buying stuff. But it's telling us that 3.4 maybe 3.2 or 2.9 trillion dollars worth of fund is spent online. That's what it's telling us right now. Now, Tim Berners-Lee was knighted by Queen Elizabeth. Who is Tim Berners-Lee? Anybody knows?
He created HTTPS.
Huh?
Didn't he create HTTPS?
HTTPS, you said?
Yeah.
That's it. You got it. That's Hannah, right?
Yeah.
That's right. So that's why the name is right there. So the Brits has been ahead in the game for a long time. So Tim Berners-Lee was knighted by Queen Elizabeth for his awesome work. You can always Google that. It's not a hidden fact. So your name is Berners-Lee. So you can see it on there on Google. Google's your friend now. Especially when the internet is working. So that's the man here. I don't even know if I spelled it right. It might not be him. Give me a minute here. It might not be him after all. Berners. Let's see what it looks like. Berners-Lee. We can find him. Yep, that's the man. You got him. Yep. He's the one that formed the World Wide Web. Okay? World Wide Web is different from the internet, right? Can somebody tell me what the internet is and what the World Wide Web is? Like the web. What is the web? What is the internet?
Is it where the internet is like a way of different networks to communicate, whereas the web is like, no, wait. The internet is basically like where you will go and look up information, transfer information, and the web is basically networking.
I think you got it the first time. You reversed it.
Okay, so the internet is the networking, and the
That's
web
right.
is where you get the information.
So when you talk about the
Okay.
internet, you're talking about the communication networking of all those information. So in the internet, you have the library. But in the web,
Okay.
you're only talking about that particular information. Maybe that particular page, or maybe that particular application, maybe that particular software that's connected to that particular one, the enclave. But it's not all of it. But in the internet, you're talking about the communication links, the traffic. That's internet. So you have the net, the big old net, and then you have internet. Going from this net, meaning going from this network to the other network. And now they're all mashed together. So that's your internet. So an email takes around 2 billion electrons to produce. Online data generates approximately $1 billion every year. I didn't say it. I mean, online dating. That's big business. And now, QWERTY was designed to slow you down so that the keys would not jam while using a typewriter, for which the layout was originally made for. You guys remember what QWERTY is? Let me see who remembers what they are referring to. Anybody?
Hand placement when you're typing.
Exactly. Hands plus space when you type in. That's ergonomics of typing. That's right. You got it. These are fun facts for the networking that we're talking about. Last time we discussed about OSI model, and today I'm, you know, pretty much giving you guys this website here. This is all you need to know about networking is on that website. But today we're going to go through a few things. We will look at addressing. Not because it's the main topic, but I think it's important for us to know before we move forward. So in the internet, to make the internet possible and to make everything that we are doing over the network, our communication possible, really smart people came up with a way of pinning down all the computers, all the phones or whatever with something, a number. Not just a number, any number, but a number arranged in a certain way. So in computer networking, you have classes of addresses. To be specific, these addresses are Internet Protocol addresses, IP addresses. So there's an arrangement, there's a pattern to the madness for IP addresses. So you have class A. So the class A will start from 0. So when we say we start from 0, we talk about the first bit on an IPv address is 0. In that case, this means that the address is part of a class A. This means that any address from 0 to this 127 is in class A. So look here, this is the secret. Make sense? Make sense? So this is the address, network address. This includes the network address. So this is the net mask. Okay? So from 0 to 127 here, that's basically what it's telling you. Make sense? So this one here is just telling you this is 0, this is 1, this is 2. That's a what binary notation, right? This is just binary notation, if you guys remember. 0, 2, right? 3. Binary notation, remember? 4, right? So these are the first 3 bits, okay? It seems to me that there's something going on this one. So if this is 1 and 2, and this also is 1 and 2 and 4, then this couldn't have been a 4. So I don't know exactly what they did here, but let's read what they say. They say this class includes addresses that have 111 as their first 3 bits, and 0 for the next bit. And this address range includes address from 224.00 to okay, I understand what they mean. Okay, disregard what I said, okay? So basically here, you are looking at this. The class A addressing, these are all 0. Okay? Then the net mask is all these are 0, and then it goes to here. So 0 to 127 is class A. 0 to 127 is class A. Now 128 to 91 class B. And then 192 to 223 is C. And 224 to 239 is D. That's where we're going to stop. So now, some smart people have specifically figured it out, okay, how to put these numbers in the order so that we can effectively use them in communication. So for instance, we have, let me go to Pent. So for instance, we have, okay, say we have here class A, they taught us that class A, these are all 0 for class A. Class A addressing, these are all 0. So now 127, right? And the rest are like 0. So the leftmost bits here are all 0. The leftmost bits are all 0 for the network addressing, which is right here. This is A, class A. Alright? So now remember what I taught you guys. So it means that if you take 2 and raise it to power 8, that's the possible number. That's the possible number of bits for each one of them. But there's something interesting going on here. These zeros that you're looking at is not just a 0 just for that one 0. It is a 0 that have 8 positions like this. Remember when I started showing you guys this? It's like actually like this. So this is like 2 raised to power 8 on each part. 1, 2, 3, 4, 5, 6, 7, 8. Then you have a dot here. And you have another one. That's what they mean. Okay? That's what they are saying. As you can see, each of this, like this one is 2 raised to power 8. Like from here to here, that's 2 raised to power 8. That's this. So each of the bits could either be a 0 or 1. 0 or 1. Then there's 8 of them. If you look at the left octet, this is the leftmost. Leftmost. This is the leftmost. Okay? And you know you're gonna have 4 of them. So the rightmost is gonna be on towards the right side. So I'll draw it out with a different color. So that way you'll see it. Okay. So you have this one, this one, this one, this one, this one, this one, this one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you have this one, this one, this one, this one, this one, this one. 1, 2, 3, 4, 5, 6, 7, 8. Okay. They are telling us this is the right. This one here is the rightmost octet. So each like this is a bit, which could be 1 or 0. This one is a bit, which could be 1 or 0. So they are telling us that for class A addressing, you can only have numbers going from all to 0 to. Does anybody remember 127 how to write it? Help me out here. Do you guys remember this? 2 raised to power 7, 2 to 6, 2 to 5, 2 to 4, 2 to 3. Somebody's having a problem. They keep logging in and out. Oh, this is 2, sorry. 2 to 2, 2 to 1, and 2 to 0. You guys remember that? So I need 127. Can somebody help me? I need 127. I need 127. I need help.
I'm trying to figure out, is it 3 times 7? 127 will be.
I know 64 is going to be there. I know 32 is going to be there too. Can somebody do the calculation real quick? I know 64 will be there. 32 will be there. So we have 96. 64, 32, 96. So what do we have left? 4 and 27. So we have 31 left. How do we get 31? How do we get 31?
16 and 18.
16 and 18. So we have 16 and 18, but 18,
13, 8, sorry, 8.
16 and 8, right?
Yes.
So what we need to put a 1 here. And what else do we do here? We put a 1 here and the rest are 0.
No, I think everything else is 1, 2.
Yeah, we made a mistake here. There's a 1. There's a 1 somewhere.
It's 0, 1.
There's a 1 somewhere. So we have 96, right? 96 plus 4 is 100. 102 plus 10, 112. Then where do we get, what we have now is 112. Where do we get the other one? 112, what is left?
I think it should be 64, 32, 16, 8, 4, 2, and 1.
Okay. 8, 4, so 8, 4, 2, and 1.
1.
Okay, so this is it, right? So now all these ones will be full because the people that are smarter than us say this is how it's gonna be. For you to have this class of addressing, all these have to be full, assume full, and then 1, 1, 1. So these are on. So you can go from 0 to here. So all the addressing that will fit in here will be from there to here. But guess what? We don't even use this class that much. It's not used. Okay? Then you have class B, which make more sense to me. So in class B, you have from 128 to 191. So that means the same thing we did there, we have to do for B, you have to do, instead of starting from 0, it starts from here. Doesn't it make sense? See? Makes sense. Then the rest are 0, 0, 0. Okay? That's B. B starts from 128. 127 is a look back. Remember, I told you guys earlier on. So C is gonna start from okay, 127 to 191. So C is gonna start from 192. So C is gonna start from 192. So which in this case you have this and this, right? 128 plus 64. Right? Right, guys? Right? Is everybody there? Is everybody there? They can't hear me. I know. Oh man, they froze on me. Hi, Agatha. Oh, okay. I kind of restarted. I hope you guys can jump me back on here. So hopefully it will come back up. We are going to revisit that again. You can hear me now. Home network shut down. I have to upgrade my network. It's not going well here. This is sheer technical difficulties. Sometimes what we are doing here, I don't know why they do that. It's not benefiting them anything by sabotaging it. Makes no sense to me. The problem is the internet. I don't know how to solve it. The problem is the internet.